Our next speaker is Dr. Scott Pace. Scott was appointed the Executive Secretary for the National Space Council in August of 2017. The Council, of course, is chaired by our Vice President, Mike Pence. Dr. Pace was formerly the Director of the Space Policy Institute and a Professor of the Practice of International Affairs at George Washington University's Elliott School of International Affairs. He's also served previously as Associate Administrator for Program Analysis and Evaluation at NASA and as the Assistant Director for Space and Aeronautics in the White House Office of Science and Technology Policy. Dr. Pace has also worked for the RAND Corporation and the Department of Commerce. He's a former member of the USRA Board of Trustees, a former trustee of the Summer Science Program Incorporated, a member of the International Academy of Astronautics, and an associate fellow of the American Institute of Aeronautics and Astronautics. Please join me in welcoming Dr. Scott Pace.
Okay. Good afternoon. Nice to see a lot of very familiar faces here. So this is one of these places where you can make inside space jokes and you know somebody will laugh because I'm part of this community. So also, first of all, again, thanks to Dr. McNutt presentation. As a side comment, I think she performed a yeoman service in keeping Landsat alive and going and progressing. I was part of the Commerce Department when we were directed to get Landsat out of the department. And it went on a long journey since then, and it was quite a torturous one. Of course, very disappointed with the launch loss. But then the efforts of the U.S. Geological Survey to keep continuity of data of Landsat, is something that it is a gift for years to come. I wanted to open up not only with thanking the University Space Research Association for hosting this event, because Americans achieved 50 years ago what was once thought to be impossible, landing of a man on the moon and returning him safely to the Earth. Now, USRA came almost at the beginning and at the end of a period there in space exploration. USRA was definitely formed as part of this bold endeavor, and NASA Administrator James Webb and the National Academy of Sciences President Frederick Seitz, as you heard, had a common vision for the crucial role of the scientific community in space exploration. Now, created initially to manage what became the Lunar and Planetary Institute, USRA has quickly expanded to all space-related science activities, and when I served as on the board of USRA, it was really truly astounding to see the breadth and range of engagements that the university community members of USRA had. And today, USRA is a vital organization for the space enterprise, bringing together not only universities, but also government agencies and private industry increasingly. So this isn't simply an organization that talks to the government and takes a check, but actually is active engagement and a partner in the more complex space organizations that we have today. We have a much more, many of you heard me say, a much more globalized and democratized space environment, with many more private sector players, many more international players. And so the flexibility and adaptability that USRA has, I think, has played a vital role in that expansion, and I think will continue to do so. Now, if you fast forward 50 years, the America of 2019 is certainly very different from the America of 1972, and not just in terms of who's in the photographs. The last time humans ventured beyond the close confines of low Earth orbit in 1972 is really, really far away institutionally. It's really almost a couple of generations. So while people can say, well, we've been there, done that, that's really not quite true. When people do say that to me, I often point out that maybe your grandfather did that, or maybe your PhD dissertation advisor did that, but a new generation has not done that and has not journeyed beyond low Earth orbit in a very, very long time. And so while the geopolitical threats that propelled us to the moon have certainly evolved and changed, in some cases diminished, the desire to explore has remained, and there are new geopolitical challenges. And so today, nearly half century later, we can see a horizon full of possibilities for exploration potential untapped. Starting in 1969 and lasting only 3 short years, NASA completed 6 fully successful expeditions to the lunar surface, exploring a diverse but limited set of sites at mid-latitudes on the near side of the moon. But at the time of that first landing, the Apollo program really was already ending, as the last 2 of nearly a dozen newly minted moonwalkers splashed down in the Atlantic, NASA turned its attention to low Earth orbit, leaving unused Saturn V rockets to slowly rust. I'm really glad they put covers over them now, because that was really a sad sight. The shift in focus, however, was inevitable. Apollo was an expensive endeavor designed for a single goal, optimized for a political result, and not sustainability. But the desire to explore once again, venture into deeper space, was never extinguished, but rather needed the right environment to be ignited once more. And that time is now. The Vice President knows that Americans are not satisfied with the status quo, that the future is truly open to those bold enough to take hold of it. And so what makes this return to the moon different, you might ask? Well, the great explorers of the past, first of all, didn't stop with a few expeditions, never return. Even if there were great pauses of many decades, as was the case of the exploration of Antarctica, some 40 years, the exploration of unknown lands persisted. And today, we're not returning to the moon merely to add a few more flags or step out a few more footprints. Instead, we're embarking on a new journey, one without an ending, but one that continues a story of never-ending firsts. What does this renewed effort look like on the moon, and what does it truly mean to explore sustainably and with commercial and international partners? First of all, it means that we're smarter about our methods, more efficient, hopefully with the resources required, and unsurprisingly, American innovation is paving that way with industry. While NASA sole-sourced almost every element of the Apollo program, today we have a diverse range of space-capable entities across both commercial and international domains that we intend to take advantage of. Capital investments in the past have led to new technologies and been great achievements, again, as Dr. McNutt mentioned. And so future success depends on our willingness to continue to invest in American ingenuity. Now, this ingenuity, despite popular media, is not limited to private entrepreneurs who require business cases to close, but includes universities and government agencies. Our investments in space exploration and development are investments in the diverse strengths of our nation and in the expansion of American values into the space domain. Things such as rule of law, such as respect for private enterprise, such as freedom of speech and innovation. So these things may seem far removed from maybe the practice of science, but in fact, actually, they're quite integral to it. The American system of innovation, the global scientific enterprise benefits from free speech, it benefits from partnerships with industry, it benefits from innovation. And so the practice of science and the openness and innovation of science is dependent upon a common culture that also is open to these things as well. So as people have heard me say, it is not merely our machines that we send into space or even people, but really it's our values. And what are those values? And we want to see them expanded and sustained, and the scientific enterprise is an integral part of that. Now, at a technical side, this also means having an orbital platform able to ensure reusability away from the Earth. If we continue to do things as we did in Apollo, it can't possibly be sustainable. And so the ability to transfer back and forth between the Earth and the Moon requires several tons of fuel. And for most spacecraft, once that fuel is expended, the useless spacecraft is discarded. While necessary in some instances, that's not the most obvious and efficient use of costly resources, certainly costly to place in space. So instead of abandoning expensive vehicles after a single trip, we should contemplate creating a fuel depot to enable repeated visits to the Moon and pave the way to Mars. And that's exactly what NASA has proposed with the Lunar Gateway. Placed strategically in a unique halo orbit around the Moon, the Gateway is ideally located as a refueling station, and if not ideal in all circumstances, it has the charm of it can move. While physically much closer to the Moon than the Earth, it's readily accessible to existing Earth-based commercial and international launch vehicles. And with the Gateway, lunar landers can now be multi-use systems rather than future space junk. And initially, the Gateway is going to be very small, but it may grow as traffic between the Earth and the Moon increases. Third, it means establishing a near-term sustainable goal, one that naturally extends once Americans return to the surface. And part of this means we need a lunar field station to conduct exploration of the lunar surface and enable multiple sites from that station. We, of course, think that the location for that field station should be the lunar South Pole. We've explored desolate locales before, extending exploration activities beyond a strategic base of operations. And an analog, not perfect in some ways, but certainly an apt one, is the McMurdo Station on the Ross Island in Antarctica. Operated by the National Science Foundation, McMurdo has now more than 1,000 residents every summer, and with a permanent presence at McMurdo, the Antarctic continent is now widely accessible for a multitude of research activities and exploration expeditions. The lunar poles have the potential to provide a similar function for lunar exploration due to their unique characteristics and due to the slow rotation of the moon. Again, as many of you know, the near and far sides experience 14 days of constant sunlight, 14 days of constant darkness, and a continuous 28-day cycle. As a result, the surface temperature can range dramatically from very hot to very cold, and solar power systems are often very challenged over that cycle. Now, however, the higher elevation locations around the poles are exceptions to that cycle with access to near continuous sunlight, enabling solar-based power systems. In addition, the combination of a near constant sun at low incidence angle results in less extreme thermal variations. The poles are tricky. For those who are thermal engineers, you know there's a lot of devil in those details. Now, these characteristics make establishing a permanent station much simpler compared to other locations on the moon, and thus a lunar South Pole station can be an access point to the rest of the lunar surface, similar to how the McMurdo station provides support for accessing the rest of the Antarctic continent. And of course, I might point out that during Apollo, we weren't really capable of accessing the polar regions. The delta V required was too high, so this will certainly be a new endeavor that's never been accomplished before. In addition, lunar poles provide access to the most important resource for humans, water. Recent investigations by Lunar Reconnaissance Orbiter and other lunar missions have confirmed the presence of water in permanently shadowed craters at the poles. These untapped resources could provide a sustaining source, air, water, even rocket fuel. Now, like the gold rush of the 19th century, it's possible there will be a new water rush on the moon, in which the prize is not wealth alone, but the expansion of humanity to another world. But it's just as possible, dare I say it, that it's a dry hole. It's also possible that we can't extract that water, that it's not economical. The answer is we don't really know. And one of the issues, I think, before us very much where the scientific community is needed is to characterize what this water ice looks like, how it's trapped, how it's contained, whether or not it's economical to extract it, whether we can use it. These are all things that people, I think, have some faith in and believe in, but we actually don't know. And so the purpose of exploration is to answer those questions, because depending on the answer to those questions, we are going to be in very, very different situations, whether it's going to be a sustainable access to the moon or whether, again, it's going to be something that's done in a bit of a sprint, before we have to move on. There are other ways, of course, to get oxygen out of the lunar rocks, but of course hydrogen is its own special thing. And so again, the near-term part of this exploration effort for returning to the moon has a very strong role for the scientific community, particularly with robotic landers, because really only the scientific community can deliver the answers for longer-term sustainability. And finally, I'd be amiss if I didn't point out that the South Pole region itself is of scientific interest. And we expect that astronauts will be able to make traverses from the South Pole Station, learn about the first critical billion years of solar system history, a key period after which the Earth formed, lost on Earth, of course, but readily accessible on the moon. Now, planetary field geology is, of course, crucial, but it's not the only reason to send astronauts to the moon. And we expect the Lunar Field Station will enable fundamental advances in other important fields, ranging from astronomy to material science, as defined by numerous community assessments over the past 2 decades, including a National Academy workshop in 2007, 2016 League Lunar Exploration Roadmap. Now, of course, I recognize no scientist wants to depend on the manned space program to go there, but science is going to be an integral part of whatever we do in explorations. And so we want that science to be guided, of course, by the best assessments of the community and those priorities. We're going to be going for lots of reasons, of which science is but one. But on the other hand, we want to make sure that what science we do there is, in fact, driven by the community assessments, and their priorities are the most interesting things to find. So with these facts in mind, what are the basic infrastructure building blocks required for a lunar surface field station? Okay, so we quickly get into engineering. Polar field station requires habitation, power, mobility, resource extraction. One example to how to build a planetary field station, again, comes from current NASA plans for future lunar human missions to Mars. And while multiple strategies have been analyzed in the past and will likely be analyzed in the future, the current thinking, again, follows the McMurdo example, a central field station from which broader explorations can be conducted. In Mars surface plans, a multi-module base of habitable elements forms the backbone of the station. Key systems included on the surface include fission nuclear power, pressurized rovers, mining equipment, and a few habitation modules. The same systems, functionally, are required for the lunar surface, but can be deployed only a few days from Earth rather than months and years. A carefully chosen South Pole site can be powered by solar arrays in the near term until nuclear-based power is available. Radioisotope thermoelectric generators and surface fission reactors are likely to be essential to successful mining operations in the permanently shadowed regions of the lunar water, for lunar water ice and for general exploration beyond the moon's polar regions. So nuclear power is not critical for getting back by 2024, but again, certainly critical for sustainability and reusability in the future. Now, beyond enabling human presence, nuclear power can also provide real benefits to scientific missions for use on the far side, conduct a variety of experiments, powering satellites in orbit, and certainly, as some of people remember from past missions, dare I mention Jupiter Icy Moons Orbiter. Somebody mentioned, yes, that's one of those inside jokes. But certainly the attractions of very, very large amounts of available power has been known to the scientific community for a long time. And it probably wouldn't be justified to build that capability for any one science mission, but a generalized capability that can then be exploited, I think would certainly be advantageous. Now, we have a strategy of speed leading towards sustainability, and people ask, why that speed? Well, the purpose for that speed, and part of the reason why the Vice President made that announcement, was to provide focus and priority. It's very, very tempting if you have a far distant goal to analyze lots and lots of different options and put off making tough decisions and tough priorities. There's a clarifying nature to having a near-term stressing goal where you think about what's in fact really important. And we need a NASA, and we need a university, and we need an industry community that can in fact do that kind of prioritization and think through that very clearly, because what we need to rebuild is a spacefaring organization that can journey beyond low Earth orbit. We've become really good at working in low Earth orbit. The space station is a magnificent achievement. The amount of satellite servicing capabilities, EVA capabilities that we now do would have been really stunning, I think, and was stunning to those of us who looked at some of the EVA numbers back in the 90s when this was just starting. Okay, but if we're going to journey beyond low Earth orbit again, we need an organization, not just a technology, not just a group of brave people, but an organization that, in the military phrase, organized, trained, and equipped to be able to carry out those kinds of missions. And having an ambitious goal with tough priorities is a way of training that organization. So by 2024, of course, obviously I'm hoping and we're working hard to make sure we hit that date with a human lunar return. But even more fundamentally, what I think we hope to see is a nation that is spacefaring again in deep space beyond low Earth orbit than ever before. And that truly is a prize for our nation. So how do we proceed? NASA is poised to lead with commercial and international partners in the design and development of the South Pole Field Station. NASA is already examining the best polar sites for the 2024 lunar mission, and this analysis can be expanded to map the best areas for human landers, robotic landers for touchdown, locations for multi-module habitat, as well as power stations. With a strategy of speed leading towards sustainability, NASA can work with proposals from the international and commercial partners to determine mutually beneficial contributions. And just like the process that led to the construction of the International Space Station, the current plans for the Gateway, the field station will be flexible and modular. And again, we've built this in, I think, really from the beginning, quite intentionally. The deployment order of contributions, of course, will be driven by needs on the surface and objectives, as well as the needs and capabilities of the contributors. So again, I would expect to see a very minimal Gateway initially in terms of supporting what we need for 2024. I see a larger, more capable Gateway building out as we build toward reusability, and certainly in the longer term, a fuel depot to support those reusable landers. A field station is a strategic investment in research and exploration, and we should proceed with an understanding of what has made previous stations so successful in the past. In doing so, not only will we be able to set up to explore parts of the moon heretofore untouched by either robotic or human explorers, we'll be better equipped to sustainably expand human presence beyond low Earth orbit and lay the foundations for the next big leap to Mars. And I hope and would assume that USRA will be an integral part of that effort. Thank you.
Questions from the audience?
Oh, come on, you're not that shy.
So it's my understanding that NASA canceled the lunar prospector, which seemed to be an essential first step to assessing the in situ resources in the polar regions. And it seems that the program you laid out here was going to be reliant upon putting boots on the moon and doing that assessment with humans. Could you comment upon that strategy?
Sure. One of the more poorly communicated NASA decisions, of which there have been several. Yeah, no, and so Thomas Zurbuchen has got that. We're looking to, I guess, take the instruments from that. The requirements and the information needed are still there, and they're going to be part of the CLIPS effort. You know, I was around when that decision, you know, was made and asked, do you understand what the impact and what message this is to the community? And, you know, the reaction I got was, what reaction? You know, what? Like, just not really the sensitivity and awareness of it. I have to say that, Thomas Zurbuchen and Bill Gerstenmaier are working very, very, very closely together, and I think they understand fundamentally the opportunity to do near-term lunar exploration resides with the science community and with the robotic explorers. And I don't know that IRCU by itself would rise to the top of any of the decadal surveys. But it's something that we actually need to know to support exploration, and I think there's some good science along the way. So this is an area, in my view, I don't know if everyone would do that, and I'll look to Jim Green to tell me if I misspeak on the science side, but this is opportunistic science, that the need for characterization, for example, will lead to some scientific insights that we may or may not have gotten to in the regular decadal. So there'll be a bit of a tension there. But I see that as a conversation that Zurbuchen and Gerst and Jim are having now.
This gentleman, then Bill.
Hello, representative from the French Space Agency. I just wanted to know about the field station. Is there some idea about the calendar, the schedule that's for when it's gonna be deployed? Will it be like after 2024 for the first landing, or?
Sure. So the near term, and thank you for the question. I met with Yves Legal out in Colorado, and we had just this kind of conversation. So the answer is that in the short term, the focus is building the organization that's capable of going back. Okay, so that means things that aren't directly critical path in line with, you know, achieving that landing are put off or put off that critical path. But as we looked at saying, well, how do we sustain this so it's not a one and done? We're looking for the international partners initially to look at the gateway, where there have already been a lot of thinking. I know the ESA ministerial coming up, you know, this summer is looking at that. Certainly a habitation module at the gateway is very helpful, not crucial. It's not a make or break for a critical path in 2024, but it provides a lot of margin over and above what Orion has, so it certainly would be very, very valuable. The next question is building a reusable lander. So there is a broad area announcement out already on that. I know there's been some work that's gone on in Europe on some very interesting lunar lander designs themselves, and I think people are building in reusability from the beginning. So it's possible to do reusable landers using fuel hauled from Earth. Doesn't make a lot of sense, but it's certainly possible. And so you can imagine, so reusability by itself is probably worth doing even if we're uncertain at this point, you know, whether or not local resources are available. But the short answer to the question is we're talking beyond 2024, but we're talking about making decisions on the lunar lander design and the architecture and gateway like right now leading up to that. So as with Mars, it depends on when your planning horizon is. You want to have feed forward to the next thing. So people are thinking about what the feed forward to Mars is. We're thinking about what's the feed forward to the post-2024 site, and then working backwards and to say, okay, what do I need now, you know, in these landers? And so we're having those discussions with CNES and the other partners.
Thank you very much.
Scott, you can probably frame this question better than I have, because I'm sure you've thought about it a great deal, but how do we assure we haven't seen this movie before? So you go back to the late 80s, and we were making an investment in technology for exploration, the Pathfinder initiative we got through OMB and the Hill. And President Bush 41 had established policy of space policy included exploration. going to the moon, and then to Mars. In fact, when I left and was president of Civil Space and Communications in Denver for Martin Marietta, I had a vice president with the lofty title of Vice President for the Earth, Moon, and Mars. So industry got geared up. You know,
No asteroids, right? Okay.
I know.
Somebody else.
No, that came later. So anyway, we were geared up in industry to go do this. NASA prepared a plan, handed it over to the White House, multiple hundreds of billions of dollars, and kind of dead on arrival. So the key question is sustainment. How do we formulate a program that can be sustained through a series of new administrations?
Right.
We get one administration that says, forget the moon, we're going to Mars, and now a new one. But I'm sure you've thought about this a great deal, and I think it's very important to get that sustainable, politically sustainable program in place.
No, absolutely correct. I thought about this in part when I was back at university, you know, after leaving, you know, NASA, and I then watched a series of events happen, and thinking about sustainability was very much on my mind. A couple of answers come to mind. The first is one should not tie some of these efforts to any sort of individual personality or party or institution, things like that. Sustainability comes from being tied to enduring national interests that are going to be there no matter what. So in talking about sustainability at that level, I often talk about the geopolitical motivation for doing this. Now, of course, the Apollo program was a geopolitical competition, but things like the Apollo-Soyuz mission was symbolizing détente, you know, with the Soviet Union in that period of time. Bringing the bringing the international partners together for the International Space Station was part of forming an anti-Soviet coalition. Bringing the Russians into the space station was part of symbolizing that we wanted a post-Soviet kind of relationship. And so if you look at the kind of dependency that we have on space economically and militarily, and you realize that this is an area beyond regions of traditional sovereignty. Again, I was in international affairs school. In that sort of shared space where no one has sovereignty, you have to get other people to align with you and want to be part of working with you voluntarily. You can't coerce it. And so to have a sustainable program aligned with national interests such that people want to work with you, want to be part of the team, you take advantage of this globalized, democratized environment of commercial and international partners to try to have something more sustainable, which is different than we had in the 1960s. The 1960s was, look how cool I am, I can do something no one else can do. After that, it was like, okay, I'm doing cool things, but really only government can do it. Now I'm in an environment where I can have a government agency lead and do things that don't make immediate economic sense, exploration, but which enable partnerships with the commercial sector, with the international sector that is certainly more capable than ever before to advance our interests in this environment that we're critically dependent upon. So irrespective of whatever Congress is, whatever administration it is, I would argue that these interests that the United States has are rather enduring, you know, beyond that. The second thing you can do for sustainability is, and notice that I didn't say we do that because somebody watched, you know, lots of science fiction movies and was very, you know, motivated. That may be an individual reason why they participate and join the effort, but why does the nation do it? Well, the nation does it because its interests are engaged. The second is that we have to have, you know, nearer-term feedback showing value to the American people. If you tell somebody, we're going to spend a lot of money and you're going to see it in 10 years, beyond a political time horizon, that's really hard to work with. The American people, the Congress, and administration, you know, has to see a steady series of efforts that show results. Now, I think the scientific community actually has done that very well in many cases by having a series of the decadal surveys, you know, provide a ranking of priorities, and you have a series of missions that you put out there, and you know, it's not something that maybe people outside the community really think about, but the impression, I think, to the political stakeholders is, oh, they're doing something on Mars. Oh, they're doing something else with an asteroid. Oh, they discovered something about a black hole. Oh, you know, there's kind of a cadence there that, you know, of achievement that, again, shows that kind of feedback. And so I think tightening up the schedule, maybe pulling goals in, yes, have a far-term vision, but do things that are within politically realistic time horizons and that are then tied to long-term national interests, is the answer that I've come up with.
Chris?
Scott, given that all the activities you talked about on the lunar surface would require a lot of power, is it conceivable to think that the first thing you do is to put a power plant on the moon and then build the station around it?
It's a good question. On the deployment, I think one of the things that's probably safe to say is that the first thing you do is you land a bunch of stuff on the moon that we would not do an Apollo program where everything is in the 14.7 metric ton LEM that lands there and you're all carrying it on your back. That when the first astronauts, step out on that surface, the picture in my mind, still up to NASA to work, but the picture in my mind is a whole bunch of stuff that's been pre-positioned. I realize this is risky to make this analogy with, press in the audience, but it's a difference between hiking in Switzerland versus hiking in the high Sierras. Those of you who know, in Switzerland, you go from hut to hut to hut. There's pre and placed supplies and resources as opposed to carrying everything on your back. We should be using robotic capabilities that we have to pre-place, whether it's habitation modules, supplies, power assemblies, thin film solar array that a robot lands and rolls it out on the surface that creates that power plant. I don't think there's enough time in the near term before 2024 to have a nuclear power station, but maybe somebody can prove me wrong. But certainly we can do a thin film solar array for at least a while. Certainly we're seeing improvements in battery technology. But the basic idea of emplacement of supplies first before humans get there, I think that's certainly valid.
Thank you.
Scott, first, thanks for your time today. John Horak from Ohio State, of course. I resonate very strongly with your comment about going because it's in the national interest. And history has shown that space is a place where we can cooperate to promote our own national interest. You mentioned the conversation about the Russians and the Soviets through Apollo-Soyuz. So you can answer this however you might like. There are spacefaring nations in the world with whom we don't yet cooperate, but might also be able to bring some value. Can you speak on either the size of the gap or what might need to take place so that we could leverage all capabilities, and in particular, because you have a lot of universities in the room, are there things that we can do from a university perspective that might not be able to be done elsewhere but could add value? Thank you.
Sure. Okay, so I'll go for the elephant in the room. Okay, China, and the answer is that again I've given fairly continuously before I was in government and presumably after I'm out of government, is that space cooperation follows politics; it doesn't precede it. We decide what the political relationship can sustain and is there, and then we go do something. We're doing things with the Russians today, who are terrific partners in space, that given the political relationship we would not be doing with them if we had to start over de novo today, but hysteresis effects and space cooperation. So the problem is the relationship is not there with the Chinese to support human spaceflight cooperation. We can have exchanges about flight safety. In fact, we have a civil space dialogue with the Chinese. I would refer back to what we say in every summit meeting, which is cooperation that is transparent, reciprocal, and mutually beneficial. The area where I think we have the most opportunity for that with China, who have some great technical capabilities, probably is in the unmanned science areas. So cooperation on, say, the Chang'e missions, again, that Jim Green's been involved with. We would like the Chinese to reflect common scientific community values in terms of reciprocity, transparency, mutual benefit, and I think there are those opportunities. I think a lunar sample exchange, if we get input into their landing site, for example, and therefore we have an interest in what samples they pick up, be certainly open to talking about an exchange of samples with them. But things that are much more politically symbolic, like human spaceflight, that also, by the way, require a degree of trust at a very, very deep level, I simply don't see that happening. So I think we can imagine coordinating activities. I think we can imagine doing more in the scientific community. I think if the university communities can find areas for that kind of measured scientific cooperation, by the way, which we carried out with the Soviet Union during the height of the Cold War, that fall within a politically, sort of acceptable, level of effort, I think we can probably do some good stuff. There are some programs that are already happening, again, fairly modest, Himalayan watershed and all that sort of thing. But that's the greatness of the diversity of the scientific community, to find opportunities where that can happen. Now, that being said, I would actually put a caution out there for the science community, and particularly the university community in particular. We're not kidding when we talk about the cyber threat. We're not kidding when we talk about some of the ways the Chinese government works with their own nationals or pressures that can be brought to bear. Okay? It's unlike any other country that we wind up dealing with a lot. So it is a kind of a unique situation. So I think we should be looking for opportunities to cooperate, but I think we also have to be watching other behavior and thinking about our cyber threat, be thinking about our students, be thinking about export controls, because all these are part of the overhead of that engagement.
Do we have any questions online? We have one more question here. Please.
Hi, Kimberly Cartier from EOS Magazine. Much of the activity that you talked about will be led or contributed to by NASA, but given the finite amount of resources and budgetary dollars that NASA has every year, how do we ensure that we can meet the 2024 goal without also sacrificing pure scientific research?
Great. No, terrific question. And in fact, so first of all, one of the answers to that is that we need to be using the scientific community, using the industry as much as possible in order to get more bang for our buck. So we put less pressure on the NASA budget. So if we find more innovative ways, again, that's what the BAA about the lunar lander situation is about, so we do put less pressure. The other is I think there's very, very much an explicit recognition within NASA is that we have to do this with the scientific community, not to them. That this is something that has to be done with scientific communities involved in opportunities for lunar science, and at the same time, other programs such as Mars rover, James Webb, and others are going to be continuing. Now, each one of the lines of science, within NASA are subject to great pressures. We can talk about James Webb and WFIRST. We can talk about other things in the planetary science line, opportunities in the heliophysics line. Thomas Urbuchen and Jim Green deal with this all the time. But the answer is we need to have the scientific community part of what we're doing in exploration, because they're the ones who are going to give us the near-term wins in terms of robotic landers, in terms of answering some of these in-situ resource utilization, and in terms of representing the kind of rapid development and turnaround that we need. The human spaceflight community, again, people have heard me on this before, is absolutely terrific at operations. It's absolutely terrific at R&D. It doesn't have a history of doing large-scale development like shuttle and station, because they're so large, they happen over long periods of time. The kind of relatively more rapid development efforts that occur in the scientific community is also a critical skill that needs to be developed across NASA and also into the human spaceflight community. So while it's not a guarantee, I would say the reasons that the scientific community will do well under exploration is because they're needed for exploration, both technically and organizationally. And frankly, they're also needed to have the broad base of support we need in the Congress, because the Congress is very supportive of the scientific community. And again, we have to do this, with them. And the way we hope to square the circle is with more commercial partnerships, with international partnerships, and to try to go as rapidly as we can in order to control those costs. Thank you.
Please join me in thanking Dr. Pace.